because it's going to be covering the last internal. Now, for this internal, the 91161, if you look at the title of the standard, it says there in two parts, demonstrate understanding of the chemistry. So if you don't show your understanding of level 2 chemistry, you're not going to achieve. So this is important to understand, because a lot of the things that we, the links and so on that are out there are for Joe Bloggs, the public that doesn't know anything about chemistry. So they are normally written at, a basic science level. The formulae could be incorrect. So what you've got to do is, we give you all these links to look at, but you must use your own understanding of level 2 chemistry to make sure that the correct chemistry comes out. So that's the first part. The second part to the standard is the development. So you've got to show how this technology has changed. So for the first part, you've got to ask yourself what chemistry is involved. So as you read through all the links, think of everything relating to level 2 chemistry. And for the second part, for the development, think of what caused the change. Were there any laws involved that resulted in this change? Was it an economic reason? Was it an accident? What sort of helped or hindered this development? Were there any changes to the design? So the first design sort of worked but could have done better. And why were those changes made? Why was the second design better than the first? So those are the two things we are focusing on when we assess your standard, when we assess your report. Now, you don't have to have a handwritten report or a typed report. You can give a presentation. What I don't want is a PowerPoint, because I find too much that students have put things in from, cut and paste, and then they don't achieve. So I find a PowerPoint tends to encourage that, because they don't write very much writing, and you just put in lots of photos that you've got from the internet, and we go, where's your original work? To show your understanding, we can't find anything, not achieved. So if you make a movie of yourself talking about it, that's great. You're showing your understanding, because we can see your face and you're talking about it. If you write a report and you make sure it's all in your own words, then again, that is great. Now, does anybody else want to give a different type of presentation? Because any sort of presentation is fine. You've just got to demonstrate your understanding. What sort of things are you going to be going for if you do the standard? Nobody's sure yet? Haven't thought about it? So you can do a poster, but again, with a poster, be careful of making sure you're showing your understanding and that there's not, very much cut and paste, because that won't work. Okay, so we give 2 topics for the standard. We want to expand it eventually, but at the moment there's just the 2 that we offer. The one is catalytic converters, and the other one is polymers, and in particular the polytetrafluoro ethene polymer. So that's the one that's used is Teflon in Gore-Tex, the same sort of polymer. So all that sort of stuff. So let's look at the catalytic converters, because this is what a lot of students choose, because all you have to have done is as long as you've got some level 1 chemistry behind you, the redox chemistry, and then you should be able to do this one, because you have to have done the redox chemistry, and you must have done something on rates. So either the 2061, which covers rates, or if you've been with us before, then the SC 105.4 would be okay, or if you've come from another school, as long as you've done the 90944 on acids and bases, because you must have understood rates and the factors affecting rates. Okay, so remember those 2 points you have to have, the development and the chemistry. So the first one is the redox. So what you have to ask yourself is, can I work out what the oxidant is? Can I work out what the reductant is? Can I show that I can work it out by using oxidation numbers? So all what you did for the redox, when you were going, this one has been reduced because the oxidation number has become more negative, showing it's gained electrons, all that sort of thing, all that you've got to show. Okay? Can you write equations? We're expecting to see a good number of equations, so not less than 5. You should be able to show these equations to represent your understanding. Now that's more or less where I got to the PowerPoint, because I was just frantically trying to do something else beforehand. So I'm going to now just go and show you the task and the links and talk you through it. And please, any questions, because I feel as though all I'm doing is talking. So if you've got any questions, please type it in, because that gives me a better idea of what you're looking for. Okay? There's definitely silence. So, okay, yeah. So if you think of questions, if you're planning on doing, first of all, let me ask, are you planning on doing the standard? So you are. Great. Okay. So let me go. I'm just going to escape this, and I'm going to go to, this is the task for the one on catalytic converters. Hopefully you can see that catalytic converters there. If you look down the task, okay, we give you the assessment criteria. So if you have a look at the task, and I'll just move it further down, sorry about, I hate it when somebody scrolls in front of my eyes, but our assessment schedule is pretty much what you see here, okay? So we are looking at, why do we have catalytic converters? Okay, so the difference really between an achieved or an excellence at this level is, if you gave a bit more depth to your explanation, that you gave more of an explanation explaining the background. Here, you know, if you just simply said we needed catalytic converters to try and improve the air quality coming out of the exhaust, but here, you know, give a bit more detail about it. Then if you just describe the issues, so things that are involved here is, for instance, petrol in the past had lead in it, and the lead would cover the catalyst and poison it, so it couldn't work. So it's pointless fixing a very expensive catalyst to your car if it's within a month or less, or a week or less, it's not going to work. So all that, those law changes was are important to enable the development. So there is a Clean Air Act that was done in the States. Please mention that that was done in the United States and not in New Zealand, because a lot of people just say the Clean Air Act of so-and-so, and I go, I don't know any Clean Air Act in New Zealand at that time, and we live in New Zealand. Okay, so just mention that was in the United States. So all those sort of things, the fact that, you know, when the catalytic converter was first invented, when was it rolled out to the cars, why? Again, it was all really economic reasons, more than anything else. So, but however, that's a background, so don't spend pages on that. 4 typed pages is more than enough. Okay, so that's just the general background. So we needed to have unleaded petrol. We needed, nowadays we have the ability to monitor the oxygen going through. So all catalytic converters have oxygen sensors. Now if you don't know what I'm talking about, once you've gone through all our links, you'll know. And And then they describe any changes. The important one here is, of course, once we could have petrol without metals in it, we could have a catalytic converter, but there was a big major shift from a two-way catalytic converter to a three-way catalytic converter. And again, you need to look up what is meant by this. The three-way really has oxidation and a reduction chamber, whereas the two-way didn't. And that was to get rid of more poisonous substances that was being churned out by the exhaust. Then, as I say, this here shows understanding of the shape and design. Now this is where your rates of reactions comes in. What increases the rate of a chemical reaction? So if you've done acids and bases last year, you hopefully will remember something. How can I make a reaction go faster? Anybody want to have a go? Okay, some clues. Would a catalyst make a reaction go faster? Nobody wants to type? You thinking about it? Okay, so this is all the sort of information you've got to think about. So you're going to need to read up on all the things that will affect the rate of a reaction. Why do we need to have this reaction as fast as possible? Does anybody want to come up with an idea? Okay, remember we want to have this dirty exhaust fuel that's coming through turned into gases that are not particularly harmful to human health and so on. So we want to convert things to carbon dioxide and water. I know both are greenhouse gases, but at least they are less harmful than, say, carbon monoxide and nitrous oxides and so on. So if we want this change to happen and we want everything to convert, do we want the reaction to be slow or do we want the reaction to be fast? We want it to be fast. So the whole design is it's long and thin and it's done close to the exhaust, you know, where it comes straight out the engine, so it's as hot as possible. So it's the temperature, because it only works at very high temperatures. So when you just start your car, it doesn't work properly. But once it's heated up to about 800 degrees, then it starts working. So you want it long and thin with maximum surface area, so there's as much possibility of a reaction happening as quickly as possible, so that by the time your exhaust fumes have gone through the catalytic converter and out the other side into your muffler and then out into the outer air, that you've got very little carbon monoxide and dangerous gases present. So the whole structure and design is to make sure that as much as possible gets converted and the reaction happens as fast as possible. So things like surface area, temperature, catalytic converter sort of tells you that. All that sort of thing needs to come in. Then, as I say, the redox chemistry. So you'll, as I said, there's a reduction chamber and there's an oxidation chamber after that. What is being oxidized? How do you know it's being oxidized? What is being reduced? How do you know? And that's using oxidation numbers. Now, a lot of those links we give you just give you general formulae. Please give specific examples to show that you've understood it. So if it just says hydrocarbons being oxidized, and they just give a formula of CH2000, give an example of, say, octane or so on. as you read around it, you will know what octane means. And you're also welcome to always work together with your teacher if you've got any queries as well. And then, as I say, the model form, because remember I always go on about chemistry of that triangle, and I've mentioned it before, of the macro, the description, the explanation, the micro. So if you like, that's all the macro bit and whatever. Then we get to the micro, the particles, and then the model. Use proper chemical language. Make sure you have superscripts. So don't say NO2 with a 2 without being a subscript. So if you're typing, make sure that you use NO and then a small 2. So use those equations, conventions. So when you're doing your report or your explanation or however you want to present it, go through and make sure that you've ticked all the boxes. And it's now comprehensive means detailed. Okay, think about lots of detail. Every statement you make, ask yourself why, how, what, and then see if you can answer that. That will make your explanation change from quite superficial to comprehensive. Okay, so then, as I say, we give you some bullet points so you know, to help you along your way, so you know what to write about. And then we give you resources. Okay, you are welcome to look at your own research, but these would help you. So remember 2071 and 2061, or the one you did for rates at level 1, are good starters, but all of these will help you. So here, for instance, I've got here good redox chemistry. So if we just look at this one, okay, it's going to go first to so you can't read that. I mean, you can't hear that. I can hear it all. But when you click on it, can you see all the chemistry? Can you see he's first used general equations? Make sure you change it to like C8H18 or something like that. So read around that. And, can you see he's talked about the reduction chamber? But so this will all help you to it, and then you can ask, I'm going to just stop that. He sort of explains all along there, so you can learn quite a bit there. Sorry, I find it difficult to talk over somebody talking there. Any questions with the catalytic converter topic? No? Okay, so as I say, the design and everything, here I had here what are catalytic converters. So if I move this one along, this, you have to, for instance, tell me what a catalyst is. Like, that's one of the first things I expect to see somewhere, is that you've explained what a catalyst is. So here's another one that explains it, and so on. And I'm just so I don't talk over it. So any questions? You think, see it's showing the honeycomb structure. Remember that you need lots of surface area for it to work. Okay, so what I'm going to do now is the other topic, which is polymers. So this is, if you look at here, I'm going to go up, sorry. So polymers and polytetrafluoroethene. So this is the other topic. So if you'd like to talk about more organic chemistry rather than cars, say cars just don't interest you at all, then again we have the same sort of thing. We do expect those, just like we wanted to know what a catalyst is and so on, we want to know this basic chemistry. What is a polymer? how are polymers formed. Okay, now that you will find in the 2052. So if you've done the 2052 booklet, this should look familiar. So this is for polythene. You would change this to the tetrafluoroethene. So in other words, instead of all these H's on it, you would be having fluorines on it. So when this all connects up, all of these are going to be fluorines, okay, and not H's. And that would be your polytetrafluoroethene polymer. Okay, and because fluorine is so highly electronegative, that's what makes the polymer so repellent of, it's so slippery. It's incredibly slippery, and it just repels any water. And that's why we can use it in cooking, non-stick cooking. That's why we can use it in Gore-Tex, as a waterproof material, because it won't soak up water at all. Water will just stay on the surface and run off. So there's lots of information in this one as well. So explain how it was discovered. So polymers, the way they were first discovered was actually by a total accident. Okay, so you can use a bit of that as a background history. Don't go into great tremendous depth on that, because that's just like your background, just like we had that for the catalytic converters. Then, as I say, use that page in 2051, show that all those steps, talk about the fact that it's addition polymerization, show that you know it's addition polymerization. If you're not going to be doing organic, then don't choose this topic, because I want to see an understanding of organic chemistry coming here. Okay, the properties, as I mentioned just now, it's so non-slip, or it's not the other way, it's not non-slip, it is so slippery. It's, and that's because of that strong, that very electronegative fluorine bonded onto the carbon, and so it just simply repels any water. And then, as I say, show your understanding of this. So show how polymers are formed, that they're these long chains, that they're quite tough, and so on. And then again, use your typical chemistry conventions. There will be fewer equations in this one than in the catalytic converters, but we still want to see around about 3, because you might have one for polymers in the first case, and then you'd want for how it's formed for the polytetraethene. You draw the structures. Now please remember, anything we cut and paste, we draw a line through and don't mark. So if you see this fantastic diagram on the internet and you go, wow, that explains exactly what I want to have, it's a beautiful diagram and then everything, remember that will not count towards your grade. So if you want to write any chemical equations, make sure that you have typed them or you have written them. If you cut and paste from somewhere else, we draw a line through it, and it's as though you never wrote that equation. Is that clear? Yeah. We've got to make sure that you have understood how to write those equations. So you type them in, okay? You can, of course, look at Wikipedia and type in your report what you saw in Wikipedia. You're welcome to do that, but the actual, information input must come from you. So I know a lot of people just like take these images and stick it in. We just draw a line through it, and it means if you don't then have enough equations in there, you won't achieve, because for chemistry, when it says demonstrate understanding of the chemistry, we are looking at the macro, the micro, and the model. So you've got to have some equations in there. Okay, so here again, it's the same sort of thing. We give you a few bullet points. Okay, you're welcome to contact your teacher and ask for clarification of a particular thing. Please, however, don't think the teacher's going to do the work for you. So if you ring up and ask, they may ask you a few questions as well to see if you've done any search in the you know, that you sort of have an idea of more or less what it's about, because the teacher is then going to say, look, you don't seem to know anything about this topic, why don't you do more reading, or why don't you change to another topic, you know, the other one, if you find this one too difficult. But if you've got an idea and you can say, look, I found this property that makes, you know, it valuable, but I can't find any other property. Are there any other properties? We can respond to that sort of question because it shows you've done some work already and we're trying to help you. But if you're just expecting us to tell you what the properties are, we're going to say we're not doing your research for you. Okay? I think that's fairly obvious. And then, as I say, about 1,000 word length, 2 to 4 pages would be fine. I recommend typing. You're welcome to handwrite, but I recommend typing because if it comes in and we go, oh, that wasn't quite achieved, but with a bit more detail it can go up. You don't have to rewrite it. You can just insert your extra detail in that document and send it in again. Or say we say, that was actually really good and it was so close to excellence, but again I felt it was missing details under about redox chemistry. You know, you haven't shown this, that, or the other. Then again, it's easy just to insert something. Or I could say, that was really, really good, but you actually had too many things cut and paste from the web, and so, you know, then at least you can remove those and add in your own drawings and so on. So if you haven't got a scanner or anything like that, or if you aren't quite sure how to insert, you're welcome to take photos. You know, handwrite on paper, take a photo of your drawing and insert the photo. That's quite, you can do that. Okay, and then in the same way, we have all the information, so you don't have to go looking elsewhere. Everything should be in here. So like what makes Teflon non-sticky. So there's a lot of, there's history. Gore-Tex explains a bit about that. Any questions? Do you feel now, if you, the teacher's only going to send you this task, by the way, if you finished either the 2071 or the 2052. So if you finish the 2052, we'll send you the Gore-Tex one. If you finish the 2071, we'll send you the catalytic converter one. So have any of you finished either of those two booklets? Yes, you have. Okay, so if you've done one or both of them, you are welcome then to ask your teacher and say, you want to set the standard, you want to do it on the polymers, or you can say, I haven't made up my mind yet, can you send me both tasks? And then we'll send you both tasks and you can click through the links and you can decide what you understand better and what you'd like to do a report on. But as I say, the teacher only sends it once you've